Hello and welcome to today's webinar, Best Practices for Conversational AI. This special webinar event is brought to you in partnership with NetApp, NVIDIA, and SFL Scientific. Thank you so much for joining us on our first webinar of 2021. This is going to be an awesome event. This is a very timely topic, a hot topic for this year. I know for a lot of companies out there talking about leveraging conversational AI in the enterprise. So again, thank you so much for joining us. Before we get started and before I introduce you to today's expert presenters, just a few things that you should know about today's presentation. First off, my name is David Davis of Actual Tech Media, and I'll be serving as your moderator for this event. We'll be doing a Q&A at the end of the event, but we encourage you to get your questions in early. You can do that in the questions box there in your audience console. It's right next to the handouts tab if you click on questions. And speaking of handouts, there are also a number of handouts there available for download in your audience console. I encourage you to check those out. There are 4 PDF resources, the NetApp Conversational AI guide using NVIDIA with Jarvis. There's also how AI and deep learning are improving online retail, as well as a couple of very technical or more technical configuration and design guides if you want to dig into the details on the solution that you'll be learning about during this webinar. And then finally, we'll be announcing the winner of our Amazon $300 gift card on the live event at the end of the webinar. If you're watching this on demand, of course, the drawing has already occurred. The prize terms and conditions can be found in the handouts tab. On this event, we'll also be doing a special prize for the best question for an Amazon $50 gift card that will be announced, or we will be contacting the winner after the webinar has concluded. And with that, I'm excited to introduce you to today's expert presenters. Welcome, Mr. Rick Wong, Technical Marketing Engineer at NetApp, David A. Onifro, a Deep Learning Technical Marketing Engineering Lead at NVIDIA, and Michael Segala, CEO and co-founder at SFL Scientific. Rick, David A., and Michael, it's so great to have you on the event today. I'm excited as well for our Q&A session at the end of this event, where we will be bringing up live video and chatting face-to-face. But first, I'm going to go ahead and turn it over to you, Michael. Take it away.
Excellent. And just a quick sound check. Can you guys hear me? Everything okay?
Yes, sir. Sound good.
Perfect. Great. Well, thank you, everybody. I'm going to just thumb through real quick here. So first and foremost, thanks, everybody, for joining the session today and obviously hosting. We're going to cover quite a bit of topics today. I'll start and then I'll finish the topics. But, my part's going to be a little bit more on the strategic overview and mindset that everybody should really be thinking about who wants to truly adopt AI, be it in conversational AI or really across the spectrum there. Then I'm going to hand it over to my colleagues at NetApp and NVIDIA, who are going to go obviously deeper into the conversational AI component. There's a lot to this story. This is a complicated topic space. So as we go through this quickly, please, again, follow up afterwards and we can get much deeper into it. So with that in mind, let's get going. I have a few very quick slides, like I mentioned. And before I do that, I just want to give you guys a little bit of perspective on who I am and what we do, just so that level sets a lot of the conversation here. So again, my name is Mike Segala. I'm the CEO and co-founder of SFL Scientific. I did a PhD in particle physics back in 2012, really when the data science space was truly starting to take form. And coming out of a PhD program, myself, along with my co-founders, our goal and why that'll be important here is really thinking about how do we take a lot of that academic rigor and knowledge around large-scale data and really heavily algorithmic problem statements and applying that to both the commercial and the federal space. So as you see a lot of these topics and tools and technologies discussed today, right, a lot of that grows out of great sophistication and it takes a lot of mind share to be able to solve these problems and obviously deploy them into a real working environment. So I run a company. We're a US-based data science consulting company. We have the honor of working with NVIDIA and NetApp, where they're 2-time partner of the year. So, just a great collection of folks here to talk about some interesting problems. Where's the next button? All right. So just to level set first before we kind of talk a little bit deeper, regardless of the sophistication you have or the organization that you have, I wanted to take a step back and really talking about what it means to start adopting some of these technologies, because to be upfront and honest, they all come with very clear and difficult challenges and barriers when you're really first jumping into the space, no matter your sophistication. And there's a lot of big barriers whenever you're building out a new technology unit. And that is either if you're buying something off the shelf that already exists from a pre-existing vendor, or if you're developing something novel yourself, right? Both have large challenges that you're going to have to think through. And as you're doing this, right, and if you're a leader or if you're in a leadership perspective, right, you really need to think and invest from that operational outcomes perspective, right? Because from an AI point of view, it is very different than traditional kind of plug and play software, because there's a very kind of clear interlay between developing a roadmap, collecting data, thinking about technology evaluations, thinking about where your models are going to sit and how that's going to scale into production, because AI is a probabilistic problem statement that needs its own kind of infrastructure to support it, and mind share and knowledge of how to actually bring that to a commercialized effort. And you'll see a lot of this, especially in surveys by Accenture and McKinsey and all these folks who talk about 75% or more of leaders acknowledge up front that they truly struggle to derive real ROI out of AI, right? That's a very common theme. And they talk about pilots that are failing and all these things, but I'm here to tell you, right, a lot of this is truly preventable, and you can circumvent a lot of these errors up front, or at least get to a go, no go decision very quickly, by working with folks like SFL, like NetApp, like NVIDIA, who are truly professionals in that space and understand the complicated ecosystem that it encompasses, right? So it's not a single effort, right? It really takes an ecosystem to solve a lot of these problems. And I didn't know where obviously everybody's coming from or their sophistications or their verticals, but I wanted to kind of start with this slide a bit and say, regardless of your vertical, the opportunities to apply AI really span a very large array of applications, right? And here, right, you can see just a few examples of the type of work that we're working on. And the second row is around NLP, right? So we'll talk about natural language processing and conversational AI today. But the point here is to say, right, no matter where you sit from a vertical point of view or a line of business point of view, all these tools, all these techniques, all these technologies are truly transferable across these different disciplines. So if you hear something today that's about financial services, but you sit in healthcare or something of the latter, doesn't really matter, right? The general techniques and advice that is given today is transferable really across all of these industries, which is a very nice thing about an AI system, right? It is truly transferable if it's built correctly. All right. So just a couple quick slides here. What I wanted to share here is what a typical life cycle of an AI project really looks like. So when we think about data science or when we think about AI, people tend to think very hard about algorithms and the latest and the greatest methods to solve a problem and all that fun stuff, because that's the fun stuff, that's the exciting stuff, that's the stuff that the data scientists really enjoy. But what we really see in a true fashion is that to implement AI, it's so much more than just algorithms, right? You need a clear holistic strategy and implementation plan to really be successful in this space. So in our practice, along with a lot of other successful organizations implementing AI, we're working with organizations across this entire development lifecycle, right? Starting fundamentally from strategy, right? So in the strategy, it's where are we defining the starting place of AI, meaning what are the use cases that we're going after? What is the ROI associated to those use cases? What are the success criteria? What's the data? What's the standards we're hitting? And who do we hire? Who are we partnering with, right? It's really creating that true strategic mindset around an AI practice. And then after that, right, we get into this more of the data engineering pipeline, right? How do we collect data? How do we store it? How do we anonymize it? How do we scale it in production and everything else? Right. And for us, this is where we have an extremely tight relationship with folks like NVIDIA and NetApp that will stand up the compute infrastructure that will enable downstream AI use cases like the ones that we'll see in conversational AI. So after that, we kind of get into the use case development side, right? Starting at a POC, your mindset in a POC or a pilot or whatever you want to call it should be, how do we take a problem in the matter of weeks, prove it from a technical standpoint? And once we've shown that technical standpoint exists, then move it into a scalable and operationalized environment. If you have POCs that will take you months or years, you're either probably doing it wrong or you're in fundamental research and you have a very different kind of thesis statement, right? So you should really be gaining for that. What can I do in 3 weeks, 4 weeks, 5 weeks, a little bit less sometimes as well, and really kind of proving out technical capabilities. And then from there, right, then we can really think about scaling and operationalizing and then deploying these things once we've proved out the technology. All right. A couple more quick ones here. So, if you're a stakeholder and you're thinking about, the buckets that I just went through very, very quickly, and there's a lot more that you can talk about there, or that life cycle of what it means to have a true strategic perspective of AI, it's very important that you ask yourself, the technology I want to build, do I actually have the time, the budget, and the personnel and the partner ecosystem to solve these problems? Because to be successful in this space, companies need to overcome these very clear, very repeatable barriers to adoption, right? And everybody goes through this. There's a lack of talent in this space. It's not a lack of talent in general, right? But there's just so few people who are really good at this because there's so many problems that are coming up in all of this kind of applications. There's a clear lack of technology, and there's a clear lack of data to support the use cases that we want to go after. So the point I'm trying to make here is, right, it truly takes an ecosystem to address a lot of these challenges. And us, right, with NetApp and NVIDIA and everybody else, right, we're positioned here to help you guys de-risk kind of AI in general and make you guys successful. So before I pass it off and just kind of, I want to take 2 seconds and just answer the question, which I think is important as well. If you're thinking from a strategic mindset is, why now? Why do I want to spend the time? Why do I want to spend the effort? What should I bring to my leadership as a convincing statement of, yes, we're actually posed to actually think about disruption in my business? There's usually 4 main themes that we see every day advance, right? First and foremost, as a capabilities driver, it's larger data sets. And this is nothing new here, right? We see more and more data collected every day, but it's really the access to cheaper, faster, more efficient storage that allows us to train larger, more representative models at higher accuracy, right? That's the big one. At the same time, we don't only have access to more data, we have access to more diverse data from net new streams. This could be third party, social, sensors, it doesn't matter. But this unification of different data sources allows us the ability to create new intelligent systems, for instance, like the ones we'll see in a minute. That's really, really novel and really new, and it's still only in its infancy. The third big bucket is we now have access to large scale compute, mainly GPU, that we can crush these large sophisticated models in a meaningful way, right? I can do something in minutes or hours and build very, very robust generalized models. And lastly, right, every day researchers are creating tools and open source algorithms that will solve more and more complex systems. So just because something wasn't solvable 6 months ago doesn't mean it's not solvable today, right? The field is advancing so quickly, we're opening up the doors literally every day to net new problem statements. All right, so that's all I want to talk about. I hope this gives you at least an extremely quick view on the project lifecycle, some of the barriers, why now, and things like that. I'll pass it off to NetApp and then to NVIDIA to kind of deep dive into some of the deeper topics here, but I'll pick it up again at the end. So thank you, and over to NetApp.
Thank you, Michael. This is Rick Huang. I'm in NetApp AI Solutions team. So we'll be looking at conversational AI, in particular how it is transforming different industries from retail, automotive, healthcare, and others. So, we are now in this environment where video conferencing is very prevalent, and you have hundreds of millions of meetings and those transcription, translation that all uses natural language processing. And for retail, you have call centers which can be automated with conversational AI. And you have hundreds of millions of smart speakers sold each year. And also for retail shopping, now we want to have a humanless environment that's safer. And as well in-car assistance, where you can ask for locations or recommendations and navigation. So conversational AI is actually transforming different industries, and you see In the bottom of the slides, we have listed some large customers using conversational AI. And with that, I'll hand over to Davide to talk about NVIDIA Jarvis.
Thanks, Rick. So my name is Davide Onofrio. I'm a deep learning technical marketing engineer lead at NVIDIA. We focus on samples and content for deep learning developers. A platform to develop conversational AI application should have all the skills required for conversation to take place. Also need to be fast, scalable, and customizable. And for these reasons, we developed NVIDIA Jarvis. So it is a GPU accelerated application framework that uses an end-to-end deep learning pipeline. The framework includes pre-trained conversational AI models for speech, vision, and natural language understanding tasks. All these trained models are also available freely on the NVIDIA GPU cloud. In addition to AI services, Jarvis is also enabled to fuse vision, audio, and other sensors input. With the use of NeMo, as we will see later in this presentation, we can easily fine-tune models on custom data to achieve better accuracy on specific context. The goal of Jarvis is to provide all its services keeping the latency low, ideally below 200 milliseconds, which is considered the limit time budget for real-time conversational AI applications. Jarvis is currently in early access program, but it will soon release as a public beta. Let's take a look at the Jarvis architecture. So starting from the top, we have client applications send and receive signals to Jarvis through gRPC endpoints. There are two main components of Jarvis. On the left side, we have the Jarvis AI skills, which can be accessed separately and thus providing independently ASR, NLU, and TTS and CV services to the client. So all these services can be accessed individually. And on the right side, we have the Jarvis Manager, which implements fusion between the skills on the left and also provide a dialog manager, basically offering a managed way of using the skills. Jarvis runs on Triton in the background, which is our inference server, and all the models run on TensorRT, which is our inference engine. So the inference for all models is optimized for the latest GPU, including A100, V100, and T4. The whole system can be easily deployed on Kubernetes in a single or multiple pods. Okay, Rick, back to you.
Yep. Thank you, Davide. So here we will look at an example of using Jarvis to build an application. In particular, we'll use the automatic speech recognition, natural language understanding, and text-to-speech part to build a retail assistant. We call it NetApp Retail Assistant, or NARA. So the functionalities include you can think of it as a smart home speaker with web chatbot interface, so you can interact it with text or your spoken input. And the functionalities include weather inquiry, and you can ask about points of interest, and then perform inventory and price check. So next, this is what the interface look like. And we also have a demo video of how the system works. So I'll play the video. Yeah, so as you can see, you can type questions or ask directly, and the system language model, it will recognize your speech, or when you type questions, it will ask for follow-up. So when you ask about the weather, and it will provide information like temperature, humidity, and wind speed. And you can ask about different times, and it will remember the conversation history and also ask follow-up questions. So the dialogue manager, it will remember the conversation history and ask for follow-up informations if the intent from user is not clear. So yeah, so here I'm performing some weather inquiry tasks, and then I can ask about points of interest, like where can I buy a jacket in Los Angeles. So the dialogue manager will parse the location and return you with the closest store to your question and provide store rating, telephone number, and address. And you can ask other questions like where can I get sushi, and then it will return some restaurant recommendations. And when you ask more complex questions like Thai food, it will recognize it as a key phrase, more than just a keyword. And then finally, you can ask about pricing of inventory. So it will return inventory pricing with prices on eBay, and you can ask about other items as well. And finally, you can ask questions like how much is laptop memory. Again, it will recognize it as a key phrase. Yeah, so let's look at the system architecture of NARA under the hood. First, you start with spoken input, and then Java's AI as a service automatic speech recognition will output text to the dialog manager. And the dialog manager, it remembers the state of conversation and routes text to corresponding services. In this case, the Java's natural language understanding service will parse the intent and entity. So it returns the intent. For example, if it's a weather inquiry, or it's a inventory check, or it's checking points of interest with slots. So that would be the keywords or key phrases. And then it will pass these commands to the fulfillment engine. And fulfillment engine can be some APIs from third parties or just a SQL database. For example, for retail stores, you can construct a SQL database of your inventory. For example, what item is in which aisle. So that way you can have the results returned. And in cases for third-party APIs, we connect to WeatherStack for weather inquiries, Yelp Fusion API for points of interest, and eBay Python SDK for inventory and price check. So after the fulfillment engine returns the result, Java's text-to-speech AI as a service returns that audio response back to the user. So this framework is highly customizable. And for example, for fulfillment engine, you can connect to different APIs. You can connect to medical APIs if you want to ask about possible diagnosis or prescription drug recommendation. And later we will also talk about connection to Merlin recommender engine. And the other customizable part is the Nemo part. You can use it to train more models to recognize more intents and entities. So with that, next we will look at more broadened implementation or deployment of this NARA, because You can deploy this in our NetApp ONTAP AI on premises or deploy it in different cloud providers since it's all container based. So the whole architecture is fairly portable. And if you have it on premise and also in the cloud, you can use NetApp Cloud Sync to sync up your conversation history. For example, each day you can maybe have thousands of requests, thousands of interactions from the users. And after each day, you can use NetApp Cloud Volumes, NetApp Cloud CVS, CVO to archive all your conversation history. And via NetApp Cloud Sync is very easy to port your whole user interaction and use these newly gathered data to better train a model to recognize more complex user intent. For example, if the user is asking about best rated item, and then you can use it to maybe gather thousands of such question and answer pairs and use Nemo to help train your system to get a better model to able to handle more complex user requests. And later, Davide, I'll hand over to Davide to talk about more under the hood of this architecture.
Thanks, Rick. Okay, so most of the capabilities of a conversational AI application are due to its natural language understanding engine. In our example, in our case, we took BERT as a base for our NLU engine. So, and this also helps me to introduce the topic of customization with Jarvis. So let's talk about BERT a little bit. So BERT, which stands for Bidirectional Encoder Representation from Transformer, is maybe a not so recent method for pre-training language representations, which still obtains state-of-the-art results on a wide array of natural language processing tasks. So for example, Q&A task, where on a specific dataset like the squad dataset, you have a set of questions and you can ask questions to the network by submitting a short paragraph. So BERT, it is a very compute intensive and therefore it can really take advantage of the latest acceleration on the GPU like mixed precision, tensor cores, both in training and in inference. On NGC, you can download pre-trained and fine-tuned BERT models that are optimized for GPU. Usually there are two versions of BERT. A base model, which is around 100 million parameters, based on 12 transformer layers, which is faster but usually has lower accuracy, and a large model with around 300 million parameters, which is based on 24 transformer layers, has higher accuracy. It requires more computation. There are also giant models being developed at the moment, which will enable a longer input sequence as an input. So no matter which of the BERT model you want to use, base or large, they undergo to the same training process. First, they need to be pre-trained with a semi-supervised way with a huge dataset like the Wikipedia corpus. This training can take many hours or few hours on a DGX system. Once the model is pre-trained, then you have to fine-tune the model on a particular task, for example, Q&A. This process is much faster and involves the use of a limited amount of annotated data. Okay, so all this training can be performed on the with Nemo. In Jarvis, to fine-tune, in general, in Jarvis, to fine-tune a model on a custom dataset for a particular application, we use the NVIDIA NeMo, which is an open source toolkit with a PyTorch backend that makes it possible to train many type of DL models. Another important feature of NeMo is that it composes complex neural networks architecture using reusable components. And in doing so, it also a semantic compatibility check is done automatically between these components using what are called neural types. Of course, NeMo is optimized for GPU and makes use of mixed precision tensor core, and it can scale training to multi-GPU systems and multi-node clusters. Okay, so as I said, it's possible to use a custom trained model in Jarvis. Let me give a practical example. So for instance, let's say that we want to improve the legibility and accuracy of automatic speech recognition transcribed text. One may want to add custom punctuation and capitalization models. So in this case, there are few steps involved to add this capability in Jarvis or to customize this capability to your data. First of all, we start from a pre-trained BERT model. The first step is to prepare the dataset, which means that, for example, for every word in the training dataset, we need to tell to the system what is the punctuation mark that should follow the word, whether the word should be capitalized or not. After the dataset is ready, the next step is training. In Jarvis, we include all the scripts needed to run this task automatically. At the end of the training, the model is exported on with TensorRT and imported in Jarvis. So it's pretty straightforward. One other important feature of NeMo are collections. So there are several pre-trained models available. For SR, automatic speech recognition, we have Jasper and QuartzNet. QuartzNet is a small network ideal for mobile applications. For NLP, we have BERT, as I mentioned before. For TTS, we have Tacotron 2 and WaveGlow. These models are trained on thousands of hours of open source and proprietary data to get high accuracy. And it required over 100,000 hours of time on a DGX system, and they are available. All the pre-trained models are downloadable, as I said, and the model code is open source. So you can train models on your own dataset or even build new models from the base architecture. Given the huge data transfer involved using NeMo, the NetApp Data Fabric is the ideal tool to streamline this process. So now we move to a different topic. And so once you have the basic features of a conversational AI application, like an NLU engine, ASR, and TTS, you can augment the skills of the basic conversational AI system, for example, by using a recommender system. So a recommender system works by collecting information such as reviews you've submitted, purchases you've made, and other actions you have taken in the past. Perhaps more importantly, they can keep track of choices you've made. All this information is streamed into data center and compiled into huge, complex tables that quickly grows in size. So just to give you an example, they can be hundreds of terabytes large. So it's not a simple task to manage and to run inference or training on this data. Merlin was implemented to streamline this process. It's an end-to-end recommender on GPU framework. It includes tools for building a deep learning-based recommendation system. Here on the right side, you can see a diagram of a recommender system built using Merlin. In particular, you can notice NV Tabular, which is responsible for data preparation and reduces the time needed for GPU accelerating feature transformation and preprocessing. And Huge CTR, which is a deep neural network training framework. This is capable of distributed training across multiple GPU and nodes for maximum performance. So on the recommender side, we have, again, Triton, inference server, and TensorRT, which are basically our engines for accelerated inference. Rick will tell you more of the extension that we started on Nara to include Merlin. Rick?
Yes, thank you, Davide. So as Davide said, with a recommender engine, you can use it to actually tailor your response to different user interactions. For example, retailers can use a recommender engine to provide personalized discounts. And then that way, with a continued interaction from the users and the system, with accumulated conversation history, the system will be more intelligent over time. And another example is maybe you can interact with the virtual assistant over day. And for example, when you say good morning to the virtual assistant, and then the system asks you, how are you feeling today? And you can say, oh, I'm feeling well. I'm not feeling too good. And then over time, that would be a personalized wellness check. So with that, that can be healthcare applications. Yeah, so it's really very applicable across different verticals. And in the next example we'll show is an integration with NVIDIA Merlin to provide movie recommendations for users. So I'll play a video.
What should I watch tonight?
Some movies recommended for you are Old Boy, Carried, and Zero Effect.
Actually, tell me more about the movie Shrek.
The movie Shrek was released in the year 2001, and it features Mike Myers and Eddie Murphy in the leading roles. It was directed by Andrew Adamson and produced by Ted Elliott. In this movie, a mean lord exiles fairytale creatures to the swamp of a grumpy ogre, who must go on a quest and rescue a princess for the lord in order to get his land back.
Now show me movies similar to Shrek.
Movies similar to Shrek are The Maltese Falcon, Perfect Blue, and Gilda.
That's wonderful.
Great, carry on.
Yeah, so in the previous example, you see really the Jarvis framework is able to process from users' audio input to all the way the system's also audio output in hundreds of milliseconds. So this is important to make the interaction in real time. And here now we'll look at another deployment option. So what we have shown before in NetApp Retail Assistant, we implemented in NetApp ONTAP AI on premises. And we also demonstrated how you can deploy it in the cloud. And with NetApp Cloud Sync, you can archive your conversation history and move data very easily. And the other option is to use NetApp HCI to deploy the whole application at the edge. So you can imagine for maybe statewide or nationwide, you can have on-premise data centers to handle the most complex training computations. And for regional, you can use NetApp HCI to deploy a lighter edge hardware footprint. So here we show it on the right-hand side. You have NetApp HCI with T4 GPU, and we have ONTAP Select, which is a software-defined architecture to help you move data with NetApp Flex Cache or Cloud Sync over NFS. And together we can combine it with NVIDIA Triton Inference Server that talks with different inference applications. That would be client Java's applications with inference requests. They can talk to the Triton inference server with different protocols like HTTP and gRPC. And the backend is organized with NVIDIA DevOps to deploy Kubernetes. So yeah, this is another deployment option for your conversational AI architecture. And with that, I'll hand over to Michael.
Great, thanks. So just 2 quick slides here to wrap up, and then we'll get to some questions and thoughts. To visualize where we just came from, if we've done all the hard work and really thinking about what use case that we want to go after, not because it's a fun science experiment, but we truly believe that it's going to be a driver in the business, right? For instance, conversational AI can have extremely interesting and profound implications if they're given to the right audience, and those right audiences are using it to really drive some product adoption, or they're using your stuff, or they're really moving along that kind of life cycle. We're thinking about that from a strategic perspective, and then we're getting to the point where we're actually doing some of this POC development, which then initially will be about, again, can we showcase technical feasibility? And then eventually, can we move that feasibility into a true production system that your users are truly adopting? One thing that I want to call out for you guys as you're thinking about adopting such techniques is, as much as these architectures will determine how you're going to scale your systems, be it on-prem or hybrid or cloud or whatever it is, you need to really think about your end users and making sure that as you're serving them predictions, right, especially in the conversational space, and especially in some of the examples that we saw, make sure that your models are actually showing success in terms of that dialogue score, or they're actually doing something that the customer is interacting with, and they want to be constantly checked and validated by your data scientists, by your data engineers, to make sure that you're truly capturing the uniqueness of your outputs from the algorithms and matching that to what your client and your customers are trying to get to. And this is really where, if we talked about in the beginning, where a lot of these pilots fail. As you can see, NetApp, NVIDIA, they've done a significant amount of work and a tremendous job of building things like Nemo and Jarvis and Merlin to work in a fashion that, frankly, is actually pretty straightforward to stand up if you know what you're doing, right? So that's not hard to do in theory. Where a lot of these things truly fail is because for your specific application, for your specific vertical or your line of business, the use case or the architecture wasn't purpose-built for your scale or your exact generalization that you guys have today, right? So if you're going to take away from anything today, like, really note that as you design these use cases in these production systems, a lot of the work that's been done already, you can absolutely leverage, and it's really not that difficult to get started. But keep your end application in mind and know that it's not going to just work arbitrarily out of the box for your specific use case. The technology will, but you always will have to adopt it to be specific towards what your use case is and how you're going to really drive that into your business, right? That's not an automatic thing. That never will be. Everybody's unique in that space. So very last slide here. Our goal as a company is to build these types of technologies with you and for you, and obviously partner with NetApp and NVIDIA, who are the ones that are really kind of, putting out the hardware and the software there, right? As a consulting company, we work with you guys to really leverage that and make it work for you guys. When we all work together, right, this NVIDIA, NetApp, and SFL component, right, we're trying to get you over this complicated barrier of adoption. And the relationship is really much more than just fulfillment of goods and tools, right? It's really about how do we create something unique and systematic for you guys that'll drive something forward. So our goal is to close that gap, right? Because a lot of this does seem difficult and daunting. And I see some of the questions, right? How do you get started? Do you need to be an expert, right? You don't, but you need to work with people who are experts, and that will really close that gap for you. AI is hard. people like NetApp and NVIDIA make it a lot easier, but by no means is it easy. So you have to be very thoughtful about it. Otherwise, a lot of these things will fail, and that's not what we want to happen. So with that, I'd like to thank you, and thank you for your time and your attention today. And then I think we're going to turn it back to any questions.
Excellent presentation. Thank you so much. So many great points made. Michael, I really appreciated your point there at the end that this doesn't have to be difficult. I know a lot of companies might, or some companies might dismiss this as just something that is just too complicated for them. But it's great that between NetApp, NVIDIA, and SFL, you guys can help to make this possible. So now let's go ahead and bring up some resources here. We want to share with everyone for more information. Don't forget about the handouts again that are there in the handouts tab. It's now time to start our Q&A. I'm going to bring up everyone's video. And Michael, Rick, and David A., I see you. You ready for some Q&A?
Of course.
Excellent. All right. Well, let's see. First question that came in. We got a lot of great questions today. This one is from Vansanta, who's asking, does conversational AI support machine learning and deep learning and rule-based bots? Who wants to take that one?
Maybe I can start, and maybe Rick or Michael, if you have something to add to my answer. Okay. So does conversational AI support machine learning and deep learning? Yes, and rule-based both. So yes to all of this. And for example, Nara in his first version was built using a rule-based boat. We move in between states of a state machine. When Jarvis will be released, we will probably have a more sophisticated way of move into the dialogue, into the conversation, even including deep learning trained states. Because one of the problem of having like a rule-based bot is that you need to design the state machine, the diagrams, and it gets pretty large, huge, very quickly. So one option is to use deep learning to simplify this. Indeed, with the version of the Jarvis will be public, we will probably release also another sample which interface with RASA, which is one of the most universally known chatbot framework, so that the integration between what it exists already and Jarvis will be easier. And yes, hope to have answered the question. And I don't know, Rick, Michael, do you have anything to add?
Yeah, I mean, maybe I'll just add a little bit to the question here. From a conversational AI perspective, it's going to be domain and use case specific. So if this is about fulfillment of orders in retail, conversational AI, as what they've shown already, does a fantastic job of kind of contextualizing and understanding some of the basic questions, and then hopefully serving some basic recommendations. So, the goal is to couple all and everything together, be it ML or deep learning or rules, right? Like fundamentally, we're just trying to serve recommendations in a very targeted way to an end user. So you shouldn't be thinking about it as this, or this, but it's really the and of all of these things to design that specific customer experience that the AI is really leveraged to assist with. So that's more of a kind of high level answer to the question, but it's really a combination of all things to serve the best outcomes to the specific end user.
Okay, excellent. Great answers. Next question, this one's from Alex, who's asking, is Jarvis available for any other services outside of retail and shopping?
I mean, I'll just say we use Jarvis. Oh, I'm sorry, David A. I was going to say we use Jarvis in nearly every vertical that exists today, from automotive to healthcare to the DoD and everybody in between. Jarvis is a general purpose AI system, not a vertical specific tool. Sorry, I didn't mean to.
Exactly. This is just an example. No, Michael. Yeah, I was answering the same. So it's just a framework, so you can use it and adapt it to your use case.
Excellent. Excellent. It's great that there's so many use cases for this. Next question, using conversational AI, how much time can we save? And also, does it continuously learn from our organizational knowledge?
Yeah, I think I can take this. So as I demonstrated, you can maybe start with a rule-based conversational AI system, and over time, when you accumulate user interactions in form of conversation history or maybe other user feedbacks, and over time, when you accumulate more data, you can use that data to train a better model. So for your question, that would be leveraging organizational knowledge over time, right? So yeah, so it's the framework is customizable, and the components like models within the BERT model, the NEMO models, they can be trained better over time using more data that you accumulate.
Cool. So these systems can learn. That's amazing to me, and really so powerful to be able to learn over time and just improve, almost like a real employee. Next question comes from Susan. Does increasing the use of AI add new security concerns? This is a two-part question. Will we have to deploy new cybersecurity tools just to protect AI? Who wants to take that one?
Well, maybe I can start, and then
Yeah.
so that's a very good question. I would say yes, but also that the tools to protect AI will probably be based on AI itself. In fact, yes, I have. I know people. I know some startups. Some that is already working in this area using cybersecurity using AI tools. So yes, there is gonna. For example, um, the sample Rick was so in the chatbots realm, you can have an open domain chatbot, right? And the reason to have an open domain chatbot that freely try to propose something to you that is very friendly.
Yeah, maybe I'll pick up there while he's
No,
going. So
David.
yeah, so I'm going to answer this question a little bit different to start, and then we can get back to more of the practical from the cyber perspective. One of the difficultness with AI in general, especially around conversational AI, and we've seen this even in the news recently, about a couple months ago, was an output from AI is probabilistic in nature, meaning every single time it's not going to be a discrete output of yes or no. So when you think about traditional rules-based approaches, you can say, is it less than 50? If so, do this. If it's more than 50, if so, do that, right? And you can follow a very hierarchical tree, and things like that are very easily to discretize and understand. AI in general, and I think this is where Davide was going, is it's probabilistic in nature. So although sometimes you think you're building an altruistic and very nice and happy chatbot, at the end of the day, it starts to, give foul language or become racist and things like that. And that's actually what happened in some of the chatbots that were released. I forget who did it. Maybe Facebook or somebody did it, a year or so or half a year ago. The evolving of probabilistic models is something that it's hard to know because it's probabilistic by nature. That's a concern. That's a little bit different than a cybersecurity concern, but it's definitely a security concern. On the cybersecurity side or things like that, it's not like you're opening up new ports or you have more threats or vulnerabilities or things like that. It's a very different type of security concept. I think if you guys should really be focused around what does it mean to take a probabilistic model and inject that into an unknown outcome. Even if you're 99% accurate, there's still 1% of the time where you might not be correct. What does that really mean for you as an organization? That's where you should be spending a lot of time and attention thinking about when you're building and deploying such models.
Yeah,
Okay.
and I can
Great point.
I can add something to the security perspective. So it depends on the individual frameworks and services that you use. For example, for data management, if you use NetApp ONTAP operating system, that encryption is built in. So for that, you don't have to worry about your data breach, your security in terms of data management. So it really depends on how each component you pick, whether they are secure itself. Yeah.
Great point. And David, we see you're back. Did you want to continue your answer?
No, sorry, I was offline for a few seconds. So I agree with Michael, making a distinction between what kind of security concerns you have. There are from the AI perspective, from the cybersecurity perspective. So yes, totally, I agree with him.
Okay, excellent. Well, let's see. We've got just a few minutes left here. Maybe time for couple more questions. I know, Michael, you referenced this question earlier. Does someone need advanced knowledge of AI to utilize this? Do you want to expand on that, or
Sure.
Rick
Yeah,
or
I mean,
David?
I can add quick 2 cents. Somebody at some point needs advanced knowledge to use it correctly. If that is an outside firm like mine that you bring in, if that's internal resources, if you can, ask very kindly and NVIDIA gives you one of their essays for a couple hours on loan, sure, right? But somebody needs to understand the nature of what it means to implement algorithms and then how to think about generalizing those algorithms, track that, and really be thoughtful about productionizing those algorithms. Like I mentioned before, it's extremely different than legacy plug and play software or BI tools or things like that. The fact that they're data-driven systems that are probabilistic by nature has a profound consequence of how you're going to train, implement, and monitor these systems. So somebody needs to have that body of knowledge. There are lots of great experts. You have 3 of them on this panel today that can help you. Otherwise, you need to internalize that knowledge share if that's the way that your company and organization wants to go about adopting real AI without failing or without causing internal harm that you won't even know about because you don't even understand what the models are doing. And that's really dangerous. And that's the big security threat sometimes. So, sorry.
Oh, great point. And then unless anyone wants to add to that, the next question here, also from Alex, is does a human need to monitor or set up the training for the AI, or is that something that would be done on the vendor end?
I'll just plug in if nobody wants to go. It could be either. It obviously depends on what you're trying to accomplish.
Yeah.
If you have a vendor that's selling you already a pre-baked solution, then obviously they're going to be the ones doing a lot of the baseline training and data gathering, and they might transfer learn on your data. Other times you'll have all of that responsibility in-house. So again, it's just going to depend on if you are buying a pre-baked solution that already comes pre-trained or if you're doing it net new. And there's all sorts of different caveats and reasons why you would do one or the other. Privacy and things like that become a big concern, especially when we get into industries like healthcare and things like that, where it's not as trivial. Other industries, it's a lot more open and it doesn't matter because a lot of this data is public. So there's no right or wrong answer. It's extremely situational.
Okay. Great points. Great points. All right. Well, it looks like we're running out of time here. No more time for questions. We got a lot of great questions on this. I want to thank everyone out there in the audience for all the excellent questions. There are some we'll have to get back to after the event. Of course, I want to thank Rick, David A., and Michael for your excellent insight and wisdom on this topic. I really appreciate your presentations and handling so many great live questions here from the audience. Thank you, of course, everyone out there in the audience for joining us on the event. Don't forget to check out the handouts that are available for download in the handouts tab. There's some great resources there. Other great resources, of course, over at netapp.com, at the SFL Analytics website, and also at nvidia.com. Make sure you check those out. And finally, before we go, I want to announce the winner of our Amazon $300 gift card. That's going out to Vera Hill from California. Congratulations. We'll reach out to you to deliver that gift card. Again, thank you everyone in the audience. Thank you, Michael. Thank you, Rick. And thank you, David A. Great presentation. We'll see you next time.
Awesome. Thank you, everyone. Take care.
Bye-bye.
Thank you.